So here we've got a question on functions that has quite a few parts, but it's all going to be practice on how to essentially use functions and how to figure out when there's unknowns involved. And so we've got h of x is equal to 2 to the power of x, where x is the number of layers, or h of x is the number of layers after x folds, excuse me. And we're asked to fill in this table to show the number of layers after each of the first 6 folds for part A. And so we're basically just plugging in different values of x. You will see loads of questions like this at the Leave Insert as well, so it's good to get a bit of practice with these. But basically we're given the first 3 results. So we're given 2 to the power 1, which is of course 2. 2 to the power 2 is 4, so 2 squared, and then 2 cubed is going to be 8. So 2 to the power 4 is going to be 16. 2 to the power 5 is going to be 32. And 2 to the power 6 is going to be 64. So rather than even using your calculator, you can just multiply each previous one by 2. So we can see that each time we go across, it keeps doubling. So we can continue that pattern and just fill in the rest of the tables. So nothing too complicated so far. And then for part B, we're asked to list the elements of the domain and the range of h of x that are shown in the table above. And so the way I always remember it is that the domain is the place that we can choose x from, and the range is going to be the outputs, or the range of outputs that we get. And so if this helps at all, I'm just going to put x on the kind of left hand side of the domain, and for the range I'm going to put h of x. And so we're asked to list the elements. So rather than listing every possible kind of input or output, we just have to list the specific ones that we had in our table. So we can just look at our table and see that the x's that we plugged in were up here on the top half of our table. So that's going to be 1, 2, 3, 4, 5, and 6. And then for our range, we just look at h of x, or our outputs, and those are going to be 2, 4, 8, 16, 32, and 64. So that's going to be it for part B. And it's always good to practice kind of using domains and ranges just to get used to the definition. But once you get used to it, it is quite handy, and it's hopefully handy in this question as well for you. And then moving on to part C, we're going to have to work out the least number of folds that would be needed to have more than 500 layers. And so this part of the question is a little bit more daunting at a first glance than it actually has to be, because we already have the first 6 folds. So we can see the 6th fold here is going to be 64. So we can just start at 7 and just kind of go from 7 on to using sort of trial and error to figure out which one is the first one that's bigger than 500. So 2 to the power 7 is going to be 128. So that's not going to be bigger than 500. So I'm just going to put a little x beside it. You don't have to do that yourself, but just to kind of keep track of what we're doing here. So that's not going to be bigger than 500. 2 to the power of 8 is going to be 256. So it's getting much bigger now, but still not bigger than 500. So this is also a no. But then for 2 to the power 9, we see that our answer is going to be 512. So this is the first kind of place we saw a number bigger than 500. And so our answer here is that after 9 folds, or for x is equal to 9, we get that h of x is greater than 500. So this is the kind of algebraic version of what we've done. And that's going to be kind of something they're looking for here, is just for you to sort of reference the fact that it's going to be 9 folds. Of course, x here is the number of folds, so that's going to be grand for part C. And then for part D, we're asked to work out the number of layers after 12 folds. And we're also asked to give our answer in the form a times 10 to the n, where a is a real number and a is also between 1 and 10, and n is a natural number. So they're asking basically for a special form here. And so to do this, we of course plug in our number of folds, which in this case is 12, into our function. So in other words, h of 12, and 2 to the power 12 is going to be equal to 4096. So this is in the form of an integer. So this is our answer if it was just a natural number they wanted. But of course they ask us for a different form here, which is that we have a times 10 to the n. And so we need to do that kind of work now. The good news is a is just a real number, so we don't really have to be too worried about a. It can have decimal places, it can have, pretty much anything we wanted to. It could even be a negative number, but even though it won't be for this question. But really what we need to worry about is getting a power of 10 out of this. And so how do we do that? And so basically what this is kind of a fancy version of factorization. And so if we think about it, we've got 4096 and we're looking to take out a factor of 10, and it's going to be the largest factor of 10 we always take out. And so basically what we're going to do here is just rewrite this in order to get a power of 10 as a part of the kind of factorization. So the number we take out is going to be 4.096, because that is going to be our number, except that we just move the decimal point across until it's between 1 and 10, because that's a very important detail here, is that a is between 1 and 10. So we need the a out in front to be between 1 and 10, and so this is going to be our value of a. And so what do we need to multiply by this 4.096 to get back to our original answer of 4096? And the answer is of course going to be 1000. So we basically factorized out 1000 from this 4.096. And then to get it in the proper form, all we need to do is turn this 1000 into a power of 10. And we know that 1000 is going to be 10 cubed because 10 squared is 100. And so our final answer for this part is going to be 4.096 times 10 to the 3. And I realize that probably seems like there's just a lot been done there and it's sort of a short few lines. But I would recommend just getting some practice with these because when they get asked, it's going to be easy marks if you're used to them. And we also do this sometimes in chemistry or physics because we're dealing with either really big or really small numbers, and so it's kind of a lot of hassle to write out all the digits. But that is going to be it for part D. For part D, we're asked to explain what the following statement means in terms of folds and layers, and the following statement that they're referencing is going to be that h of 14 is greater than 10,000. And so basically, what does h of 14 represent? If we go back up to the very top of our question, h of x is just the number of layers after x folds. So we just plug in our number for x, and this is the sentence basically that they want repeated for the number 14 specifically. And so in terms of folds and layers, h of 14 being greater than 10,000 means that the number of folds, or actually the number of layers, excuse me, so the number of layers after 14 folds is more than 10,000. So that's going to be basically the statement they're looking for here. For part F, we're asked to put a tick in the correct box to show what kind of pattern is made by the number of layers. And so this is just a question about what kind of function we're dealing with here in kind of the terminology they introduce in the question. But in any case, we just need to figure out which one this is. And so we know it's not going to be linear because we know the form of a line is always going to be y is equal to mx plus c. And so we definitely don't have that here. A quadratic is always going to be x squared, or x squared plus bx plus c. And then when we come to exponential, we realize that actually this is going to be it because an exponential function is always in the form y is equal to a to the x, where a is just some number and x is actually what our function is increasing in, and so this is going to be an exponential. And so we just tick that box, and that's kind of a test of knowledge on do we know the different types of functions and how to spot them. So for part G, we're told that after a certain number of folds there are k layers, and we're asked to figure out how many layers there's going to be after 3 more folds and to give our answer in terms of k. And so I've just written our function again here, so we know that h of x is equal to 2 to the power of x, as it always has been for this question. And basically what we're told in this question is that for a certain value of x, this h of x, or this 2 to the power of x, is equal to k. And so we're asked to figure out what's going to happen when we just fold it 3 more times and to keep k in our answer, basically. And so I think the most straightforward way to start is just to figure out what happens after 1 more fold. So if 2 to the power of x is equal to k, and then we once again multiply it by 2. So remember, we're just always multiplying our next one by 2 for this question involving folds and the number of layers. So for every fold there's twice as many layers, and so we basically just add 1 to our exponent, which is the same as doubling k. So that's what happens after 1 more fold. So for after 3 more folds, we can simply continue this pattern. So we're going to have 2 to the power of x plus 2, which is equal to 4k, and then 2 to the power of x plus 3 is going to be equal to 8k. And so basically, if you take any number of layers and call it k, the result after 3 more folds is going to be that there's now 8k layers. So k layers becomes 8k layers after you fold 3 more times, and so that's kind of what they're looking for part G. For part H, we're told that after a certain number of folds there are 2 to the power of p layers, and so this is going to kind of be using more unknowns here, introducing new letters, but just using kind of the same logic about the question that it doubles each time. And we're asked how many layers is there going to be after 3 more folds, and to give our answer in the form 2 to the power of m, where m is in terms of p. And so for this final part, I've just written down our function again, and we're just going to go through step by step in order to figure out how to write this in terms of p. So we know from part G that we can say that if we're given that it's going to be p folds giving us 2 to the power of p layers, h of p is equal to 2 to the power of p, and then after 3 more folds we're going to have 8 times 2 to the power of p. And that's coming straight from our answer for part G. So we know that it's going to be 8k for any number k that we start off with, and then just fold it 3 more times. And so h of p plus 3 is equal to 8 times 2p, or 2 to the power of p, excuse me. But another way to write this is actually just to keep our p plus 3 above the exponent. And so we can also write it as 2 to the power of p plus 3. And this is going to be the same answer as this 8 times 2 to the power of p, because h is 2 to the power of 3, and so we're just adding that onto into our exponents. And so our final answer here is going to be h of p plus 3 is equal to 2 to the power of p plus 3.